Today we're going to talk about E equals mc squared, Einstein's famous formula that I didn't know about at all until I started looking it up, and I found out some really cool stuff about it, so I want to present about it. Sorry I didn't get to present in class, but hope you guys watch this and enjoy. So we're going to talk about, we're just going to do a little intro. There's two types of physics, or I guess categories of physics. There's modern physics and there's classical physics. Classical physics is all Newtonian and Galilean stuff, like everything up to around 1890s, that time period, like 1900s. And everything after that, including quantum, nuclear, everything after that is called modern physics. So, just to go through this real fast, modern you have to know about reference frames first of all. Reference frames are well, they're called inertial reference frames. They follow Newton's first law, and that means that there's no net force on an object is at rest, or an object continues with a constant state of motion. So I know a group talked about it last week, and they kind of, a lot of stuff is a little bit of something they talked about. But so special theory of relativity is how we observe events, or also how we observe events in different reference frames. So the definition of the relativity principle is the basic laws of physics are the same in all inertial reference frames. And Galileo and Newton knew that. But they just didn't have real strong insight into it. But then this advanced in recent years. And in classical mechanics, classical physics, space and time are absolute, which means that the size of an object never changes; it always stays the same, and time flow never is constant. So time doesn't change. I mean, it's all the same. But Einstein's postulates were that all inertial reference frames are equally valid, and that the speed of light for all observers is always the same. But the consequences of that is time dilation and length contraction. Well, the group last week did a pretty good intro into that. They talked about that really good. So, or well. So we're going to talk about this theory, which is the factor by which things change due to different reference frames due to speed, and that is gamma equals 1 over the square root of 1 minus the velocity squared over time squared. And so from there, that's just the definition of gamma. We should also talk about kinetic energy. And kinetic energy is 1/2 the mass of an object times its velocity squared. So those are the things you need to know going into this to understand equals mc squared. So right now I'm just going to go through and solve for equals mc squared. And so Einstein actually proved that at high speeds, kinetic energy, which is the speed of motion basically, is not correct at high speeds. And then instead he showed that the kinetic energy of a particle at rest, which we'll call MO, is particle at rest, and that's the mass of a particle at rest, sorry. China speed V, we'll call it rho, is actually kinetic energy equals mass, the object at rest, light squared over rho minus mass. And then I only have 10 minutes, so I'm going to go real fast through this. So this actually, you can substitute this, since gamma is actually 1 over the square root of 1 minus v squared over c squared. You get this, 1 minus v squared over c squared. And you can rewrite that as k like energy equals rho that's an object at rest, kinetic energy squared, minus O squared. And then you can rewrite that again as gamma, mass of an object at rest, c squared equals kinetic energy minus mass of an object at rest, c squared. So from there, well, we actually know that you might not, but the what we call total energy is actually equal to something called this total energy. E equals total energy equals gamma mass of an object at rest c squared. So you put that into here, you get E. So E equals the kinetic energy minus the mass. Oops, this should be a plus. Sorry. And so if a particle is at rest, that means it has no kinetic energy. So this goes to 0. So then you get E equals energy, right? Squared. So what does that mean? So that means that energy is dependent on mass. So when you increase the energy, you increase the mass. That's similar to like water. When you add heat to water, you're adding energy into water. If you add energy into water, you increase the mass. So the mass of hot water is heavier than the mass of the exact same water you just heated because you're putting energy into it. Likewise, ice. You take heat out of that ice, you're actually removing the energy from the ice and therefore decreasing the mass. So when you look at it, the reason this happens is the change in the mass equals the change in the energy over c squared. And the thing is, you don't actually change the mass by that much because the mass of c is equal to 3 10 squared. Or just a second. And that's the speed of light. So the speed of light is actually this. I mean, that's a huge number. Now if you square that and you put a number in the numerator, that number is going to be pretty big to cause this number to not basically be 0. And so really the mass does change when you heat something up, but not by much because a number has to be really, really big here to cause the mass to change. If you change the energy, the mass is going to change very little. But I just thought that was really cool, and I appreciate you guys watching this. I'm sorry I couldn't present in class again, but hope this was cool. I really thought it was awesome. I'd never really understood it. No one ever knows by E equals mc squared, but I never knew what it meant. Alright, cool. Well, you guys have a good break. Thanks. Bye.